Hello everyone. So today we're going to talk about the other variant of XSS, which is a stored XSS. And this is actually more critical because when an attacker successfully uh, exploits a stored XSS, what happens is the JavaScript gets saved on the backend database. So each time a user actually visits a part of the page, the JavaScript executes. The reason why it is actually more critical than store the reflected one is because stored XSS, you don't need to set up any kind of phishing or anything because the JavaScript will be saved in the backend database on a vulnerable site. And each time the HTML renders, it would actually pull the data and execute the JavaScript. So basically, you don't have to worry too much about convincing. An attacker doesn't have to convince a victim that they need to click on certain link for the JavaScript to execute. As long as they visit the site, the vulnerable site, and the vulnerable page, then the JavaScript would execute on their browser and do the malicious act. So today I'm going to just demo a couple of things depending on time limits. I'll also try to demo how capture keystrokes are possible using JavaScript. Is actually you're going to be we're going to be using the same thing, the fetch API, and this time instead of document.cookie, we'll use what's called document.event listeners. So each time a key is pressed down, it would actually it would trigger a function to an event function to execute, and that event function would actually execute that fetch API and try to send each keystroke to an attacker-controlled site. And we're going to try to use webhook.site. Now, webhook.site does have limitations if it's a free version because a keystroke is going to be multiple requests. So depending on how that works, we're going to try to do that. But um, I'll explain all the details on what needs to be done. That way you'd have better understanding of how that works. With that being said, this is going to be what we're going to do today. The attack demo still is a session cookie, capture keystrokes to retrieve username and passwords on the site. Now, we're not going to do that, but I'm going to show you how to capture keystrokes. But if you have your own test site, you can actually try this on your site and log in with a different username and password on a vulnerable part of the page, and it should send a keystroke. But I'll try to show you how the keystrokes get sent over to a remote site. Now, the first thing, obviously, we're going to try to capture the traffic. So let's get started. Now, I've made a lot of improvements on the site. It's actually everything right now is server-side rendering because it'd be easy. At some point, I'm planning on releasing this application so people can start practicing on it. And it would be a lot easier for me if I actually set up the front end and the back end on one server. So what I did is actually it's going to be server-side rendering and it's just going to be one VM where I can run everything, the front and the back end. But you can actually access it once you set it up on, let's say, some test Ubuntu server. You can access it from a browser and start testing. But it does have all the vulnerabilities, and I added back all the vulnerabilities from the other site as well. But today we're going to be focused on the stored XSS. Now for this, like I mentioned earlier on, the way a stored XSS is exploited is the attacker would manage to inject a JavaScript code on the backend database that saves the information. So mostly you see this kind of attack on blog sites or something where a user comments will be saved on the back end, and when the page gets refreshed, what happens is the front end will make a call to the back end and retrieve all the information about the comments or whatever kind of site it is. And during that time, when the data gets rendered, if an attacker manages to actually inject JavaScript, the JavaScript executes in their browser and does a malicious act. So with that being said, let's get started. I'm gonna go ahead and I'm gonna type in this the script, the alert JavaScript on all the fields because as an attacker we don't know at this point, right? But I'm just trying to demonstrate that, so I'm gonna type it. Obviously, I know which field is vulnerable, but if you're testing, obviously you need to test each field. So I'm just gonna go ahead and do that right now. Now, the second field accepts only, it does do input validation, so I'm just going to go ahead and give it some uh, random email, something. I'm going to submit it. As you can see, it is vulnerable. The field that is vulnerable is the top one that has a name. And if you see here, this is a test. This is the one I just added. Now, what I was referring to by stored is, let's say I browse to the home page. I'm doing something, did something, and I go back. What happens is the JavaScript executes. So let's say another user logs in from, I'm going to go ahead and try it from a different browser. That way it kind of simulates another user doing the same thing. And let's start off from the home page. So another user pulls up the page. As you can see, I'm using Firefox, and they go to the comments section. The same thing happens, XSS. So now that we know that's how, because the information is stored, and obviously if I'm an attacker, I don't want alert. Alert doesn't do anything for me, right? I either need to capture something useful about the victim, or maybe steal their cookie so I could log in. So what we're gonna do, we're gonna try to build that payload so we can change the alert JavaScript to something that an attacker would use. Now, since I don't want this page, every time I come to this page, I refresh it, I'll see the alert. So I don't want that. And also I want to demonstrate and just show you what happens in the back end. So I'm going to show you this. So this is the database that actually saves the comments. In this case, I built the application myself, so I use MySQL. But basically, this is the information that got saved. As you can see, this is the one that has an alert. And that's basically what happens when you have a blog site or something like that where an XSS vulnerability has been exploited, stored XSS, the payload gets saved somewhere on the database, no matter what. Could be MongoDB or something, but it gets saved, and the information when it gets loaded, it actually loads it back and it executes the JavaScript when it gets rendered. Now, I don't, like I said, I don't want it to be affecting me every time I go to that page because I'm going to substitute it anyway. It'll be a lot easier. So I'm going to go ahead and, since we demonstrated that now, I'm going to go ahead and delete it. Now, if I go back to this page and actually refresh it, because the script is gone, it doesn't have it. Even if I go to this page, the same thing happens here. It doesn't have it. So that being said, well, I'm going to use the two different browsers to show victim and obviously the attacker. The attacker will be the one using this browser, Burp Suite browser. So we'll go ahead and clear history here, so it'll be easier. So the next thing is, obviously we need to construct a payload. We're going to do the same thing. We can use document.cookie. We can use the fetch API. So first thing, obviously, fetch is going to take on the URL, obviously, and the second part, which is going to be the request parameters. This is the basic construct. Now let's go ahead and get the URL from the webhook site. Copy this. Obviously, this is going to be post. I think we talked about it in the previous video, so we don't have to. But this is basically parameters that need to be entered. This is one of the method that the Fetch API is going to use, and also there is a course configuration and it needs to be mentioned, and you're just going to go ahead and put it as no course. And the body. This needs to be wrapped inside the script tag. Alright, so we got our payload. Let me go ahead and copy it. Then we need to execute it on the site so it gets stored on the backend database. So let me go back to the site. Now what I'm going to do is, I usually like to do it this way because it would be easier to manipulate the HTTP headers, the HTTP request body in this case, on burp. So what I'm going to do is I'm going to go to the intercept, turn the intercept on, come back here. I'm going to go ahead and submit it. Alright, so I guess this is a post API that we need. So I'm going to send it to repeater. After that, I can just drop it because I don't want to send it. I just want to get. Now let me go ahead and send it to repeater again, just in case sometimes HTTP requests might fail. That way I don't have to capture it again. I can just use other copy that I copy again. Intercept this time is off because I got the respective request already. So we're gonna go back to where I have the payload. Obviously we need to URL encode this one. Alright, so request is ready. Let's go ahead. Follow the redirection. It gets to the comment section. So obviously it loaded up, that's why I brought the comment section. So if I were to go up here and let's say if I refresh it, and you should see this is just this from a Twitter user, but the JavaScript, every time I actually do it, refresh this, the JavaScript is actually executing. And if we go back to this site now, and you can see here, we got the first one, we got the value of the cookie already. Now what I'm going to do just to demonstrate that, how it affects multiple users. As you can see, I don't have any logged in user here, and it's a different browser. So I'm gonna log in using a different, as a matter of fact, we create a new users in here just to demonstrate. All right, user register. All right, as you can see, test user is registered, a new user. Now I'm gonna go ahead and duplicate this. I'm gonna go back to that vulnerable page. First, let me go to the home page, and I want to show you that currently we only have one request where it's sending it. But as soon as I hit that, from the test user is actually gonna get their cookie too. So I'm gonna go to the comments section. Now the JavaScript executed, and it took their cookie too. So if I go back to attackers, as you can see, we got a new one, and it has this. And just to confirm that's the case, what I can do is, as an attacker, I can copy this, and I can go to, let me go to the home page. Sign in. Now I got the traffic in here. I could go back, go to the target proxy, HTTP street, login. Let me send this to repeater. Now, like we talked about last time, now since we've stolen the session key already, we don't need to do GET request to the login. Instead, we need to do GET request to an internal page. And in this case, I'm going to use welcome page. And I'm going to replace this with the session that I was stolen. So we're going to send it to 200 OK, and it does, as you can see here, it's showing everything. So what we're going to do is I'm going to copy this so we can see it on the browser. Yeah. So the attacker is able to actually get the session cookie from this user as well, and also what I can do is, if as an attacker, I have another cookie as well, the previous cookie, which is this one, and I can also use this the same way. And let's send this to repeater again. So this time I'm going to change this to the second session ID I got. And this logged in too. So I'm going to go ahead. So welcome Enoch on this one. Welcome test user. So any other user who actually logs in, they're going to be vulnerable because they're visiting that site that has a JavaScript. And also, I just want to show you something. If you go to the comment section, let's go to the victims comment section, right? Each time the victim refreshes the page, it actually executes a JavaScript. That's the reason why it's called the Stored XSS. Now, I'm going to use another browser again, and I'm going to go to a home page, and I'm going to assign it with a different name this time. Now, if I were to refresh this page, go back to localhost and go to the comment section. Now the JavaScript executed. And if I go back as an attacker, I go back here, I got the new one here. So I can use this one as well, do the same thing, go to burp, and just go send this to the repeater again, change the session ID to the new user. Send this, and copy this, So each time a user visits the site, they'll have the cookie stolen. So now this is a new person. So now that we know how this is manipulated, we had to talk about the second one. Now, I think I've discussed this in the past video, but I'll repeat it. Now, stealing a cookie on the modern applications might prove difficult for an attacker because there is a cookie feature called HTTP only. The reason why this attack was possible is because I actually designed the application, so I turned off what's called HTTP only settings on this application. That way we can demo this attack. If I go up here and I can show you the HTTP only is turned off. So I'm using the Spring Boot backend application. That's the reason why the JavaScript is able to read the value of the session cookie and send it over to the webhook site. Now there is another option where this is not required and an attacker can actually still get some information out of the user. That is actually using what's called event listeners. He can set up a JavaScript where the JavaScript executes each time a key is pressed, and so that's basically it. Let me go ahead and create. Let's look at the payload for that. It's going to use the same thing, but it's going to use the event listeners. So every time the event is going to be, in this case, key down, and the function that would execute in our case is a fetch API. I like to put it on one line. It'd be easier to URL encode. Use a webhook. We're going to concatenate the key to be sent. Let's make sure we got it. Believe yes. Function events. It's gotta be this one. All right, let's wrap it inside the script tag. I leave the command on the description section of the video. Anybody want to test it on their test environment? So that's basically it. The same, we're going to do the same thing. I can go back to burp. All right, this is the one that I use, so I'm going to go ahead, send it repeat it again so we get a sample. I'm going to change this again, the name. URL encoded. And we got it right. I'm going to go ahead and change some of this. That way we would know. It's a different one, so I'm going to, instead of Twitter, I'm going to make it Facebook. All right, let's go ahead and send it. Redirection. Comment section. So if I were to go to the comment section right now again, this is a comment section. If I were to refresh it, I should see the new comment. This is from a Facebook user. Now it should, as you can see here, we're already receiving the first key pressed. And if I go to any of the users, if they type in, let's say, sorry, my headset died. Yeah, basically the payload is already injected to the backend database. Now let's go ahead and test it. So we got this in users. .com. Now, if we go back, take a look. Let's say let's refresh this. Yeah, as you can see here, each time the key is pressed to send it over. So key press S I T H. So that's how an attacker would be able to actually capture its keystrokes. Maybe you go into the website and try to log in with your username and password, and you can have the JavaScript execute and steal your username and password. Now, with that being said, let's talk about the input validation or sanitization. Most modern frameworks, they add the greater than and less than to input sanitize anything. Let's demo what was going on in the site. So we have this comments. Let's see. I can demo it with a new one. Let's say just now this one is sanitized. So if I were to put so now if this doesn't have the comment section. If it doesn't have input sanitization, what's going to happen is this script is going to execute each time I actually refresh the page. But that's not the case here. The only vulnerable field is going to be the name. I'm going to see that I'm going to submit it. As you can see here, I did add it, but as a text. Let's see what happens here. If you inspect this, let me go ahead, edit HTML. So this is how modern frameworks would actually sanitize against it. They would add ampersand GT stands for greater than or less than. So basically it's just sanitizing it by saying this is not a script tag, it's just greater than and less than, and the HTML is not going to interpret it as a JavaScript, so it's not going to execute it. Now the reason why I was able to introduce the other vulnerability is because if we go back to, let's say, the field with a name is actually the one. Let's see the one that I actually ingested, last one, test user. So if I inspect this, this is the one that has the input validation issue. So this is actually replacing the row by value, user value, directly to the HTML. That's why it's being an attacker is able to actually exploit this. All right. So with that being said, this concludes our discussion today. Thank you.